This Week in Startups is brought to you by LinkedIn. You need LinkedIn Jobs to find the right people for your business. Post a job today at linkedin.com/twist and get $50 off your first job post. Calm. Seize the day, sleep the night with the help of Calm, the #1 app for sleep. This Week in Startups listeners get 25% off a Calm premium subscription at calm.com/twist. That's CALM.com/twist. And Rippling, the world's first way for businesses to manage their HR and IT in one system. For an easier way to onboard and supercharge new employees, go to rippling.com/twist and get 20% off. Upcoming launch events. Apply for our next Founder University September 9th and 10th in San Francisco at founder.university. And get your free Founder Pass for Launch Scale in San Francisco October 7th and 8th at launchscale.net/tickets.
Hey everybody, welcome to This Week in Startups. This is the podcast where I, Jason Kalanick, an angel investor here in the Silicon Valley, meets with investors and entrepreneurs and celebrates entrepreneurship. The biggest problems in our world are generally not solved by governments. In fact, many people would argue that governments cause a lot of the problems. And entrepreneurs are solely responsible for pushing society forward to solve the most challenging issues. I know some of you might argue with this, but you're wrong, and I'm right. Just take it's once in a while the government gets something right. They got us to the moon. They got us the internet, okay? The first version. But man, do entrepreneurs solve a lot of problems. Whether it's energy, transportation, education, all of these industries are being revolutionized because a single person, or sometimes one or two founders, will build a team and say, you know what, this crazy idea is worth trying. Now, one of the most important categories that we will see in the second half of our lifetimes, depending on your age, is AI. People being able to give decision-making over to computers, algorithms, and in this case, chips, to make decisions for us that are better than the decisions we would make ourselves. That is the promise of AI. We're not trying to make computers make decisions in order for them to make suboptimal decisions. We want them to make decisions that we're simply not capable of making because there's too much data, there's too much noise, too much complexity. And what happens if we do, in fact, enable better decision-making than the best decision-makers on the planet, humans with consciousness? Well, if we make better decisions, we could see the end of people dying in car accidents. We could see the end of cancer. We could see the end of manual labor or back-breaking labor that we do not want to do. If you still want to dig a ditch, you're going to be allowed to, but you will not be forced to. That's a big sea change. And the people who are on the forefront of this have a lot of responsibility, they have a lot of talent, and they have a lot of problems to solve. And today we're going to talk about those problems with a gentleman named Marcus Gomez, who I'm meeting for the first time this very moment. And he has a company called Luminous Computing. Started in 2018. And the reason I asked you to come on the show is because, one, AI is important. You heard my little preamble. I'm interested in your take on it.
Totally.
But I'm friends with a guy named Travis, and he started a company named Uber.
Yeah.
And he's a smart cat. And he gave you some money as an investor.
Mm-hmm.
And I noticed my friend Luke Nosik, from Founders Fund, who now has Gigafund.
Yeah, that's correct.
He also gave you a little bit of money.
A little bit.
And then this other person, William Gates.
Never heard of the guy.
Not sure what he does, but no fund. But I guess he's an angel investor of some type, also gave you money. Those three individuals are not giving money to somebody who doesn't have a great idea. Tell me, what is Luminous Computing and what is your great idea?
Yeah, so Luminous Computing is a moonshot semiconductor company in the AI space. The product we're building is the world's largest supercomputer. And keep in mind right now, the world's largest supercomputer is the size of, multiple story building. Our chip is this big and it has more compute. It's specifically for AI applications because the number one thing that every person in AI will tell you is that the reason that we're still stuck in this world where, Siri doesn't work on your phone and level 5 is this thing that's not going to happen for 10 years.
Level 5 self-driving you refer to?
Self-driving, yep.
Self-driving with no steering wheel. And
self-driving with no steering wheel.
Yeah.
Or, the reason why drones aren't flying everywhere, the reason why, data scientists, their workflow is wake up in the morning, go, put a model on AWS, wait 12 hours, and then come back and see if it's done. All of this is the same problem. They're all bottlenecked on not having just the sheer amount of compute necessary.
Now, that flies in the face of what the common technologist would think. We're all sitting here thinking, well, Amazon created this giant cloud, so did Google. Facebook also built a huge army of computers. There's supposed to be these quantum computers coming. NVIDIA's making chips that seem absurdly powerful, unnecessarily powerful. Why does any gamer need 4K or 8K at 60 or 120 frames a second to play Doom, essentially? It's called Fortnite now. They don't need this much power. What are we getting wrong? Why do people think that we've now hit a level where computing is unlimited when you're saying it's not?
Yeah, so look, I think the easiest way to see this is to take an example, right? So let's take self-driving cars. What does a self-driving car have to do? Well, first of all, you've got like 30 to 50 sensors on the car. So you've got gigabytes of data coming in every second. Then you've got a latency constraint. So from the moment an object appears in the field of view of the car to the moment the car is done reacting, you've got 200 milliseconds to get everything done. You lose half of that time just because it physically takes time to turn a steering wheel. So in the remaining 100 milliseconds, you have to take all of those gigabytes of data and turn it into a decision. In addition to this, the sheer amount of data and the sheer amount of, the short latency, you also have a power budget. So for cars, the number is something like 100 watts. And for right now, with the amount of compute that you need to put in the back of a car to make a level 5 self-driving car with no steering wheel actually happen, you'd be putting kilowatts of power in the car, and your car will probably burst into flames from overheating.
Okay, let me summarize.
Yeah.
Because this is a way of thinking about it that I think is very instructive. Solving a bunch of math problems on a spreadsheet or a database.
Yeah.
Yeah, or making a new Pixar film. Sure, or playing a video game, you can have it draw in the Pixar film and render for 30 minutes or 3 minutes, and there's no big deal. You're rendering, you can get a cup of coffee, or it's 3 or 4 seconds. 3 or 4 seconds is 30 or 40 times what 100 milliseconds is, right?
Yeah.
So the speed at which a decision has to be made is one factor.
Yeah.
The second factor is the number of sensors we've unleashed on the world, primarily because of the smartphone, which has enabled us to miniaturize sensors and make them commodities, like so cheap it's ridiculous. So you have people who are engineers saying, you know what? Instead of putting a sensor on each side of the car and having 4, they're like, well, why don't we just put 8 on each side of the car and have 30 or 40? So now you've got all those sensors. You have to make the decision quickly. And then to process all the data that's coming into those sensors, because those sensors are becoming higher fidelity, correct?
Yeah.
That's the other piece that I think.
The sensors are getting better because they need to get better.
Right. So an example of that might be, in layman's terms, the difference between having a HD 480 when you bought it 10 years ago to 720 to 1080 to 1080p to now what you see 5K, 4K, 8K screens coming out.
Exactly.
So that is literally 4 times, 8 times what we normally thought of as HD. I'm using quotes. Some of these other sensors, I think, are also getting more precise, yes?
Yeah, they're getting, you're putting like 8 or 10 LiDARs on a car. Like
8 or 10? Oh my God.
I saw one company do this. It varies per company. But you have tons of cameras. You have accelerometers. You're measuring a bunch of different types of input data. And they're all extremely high fidelity. And you need this quantity of data and this precision, the precision in this measurement to actually be able to ship something that's safe.
Yeah. So then you add to it, the application is critical.
Yeah.
So we have sensors with massive fidelity making fractions of a second decisions that are literally life and death. And on top of that, what people don't take into consideration is when you put one of those giant NVIDIA cards in your tower to play Fortnite or one of these games, Call of Duty, at some incredible frame rate, it's got 4 or 5 fans on it.
Yeah.
And a massive power supply that's plugged into the 110 volt in your house.
Mm-hmm.
Now you put it in a car and you have 4 of those, which is probably what's necessary, right? A couple of those NVIDIA cards?
I've seen 8 to 10. People are putting a ridiculous amount of compute in the back of these cars. And when, like you said, when you put these all together, it still barely works. And with this power budget thing, I mean, the cars just overheat.
Yeah.
Right.
And that's why Tesla, when they give their driving range now, when you put autopilot on, it's going to draw more power.
Yeah.
And when you go to full self-driving, their range is going to go from 200. Well, I think now their cars are 350. But a self-driving car might use, what, an extra 10, 20% of that energy?
I mean, for reference, for every 100 watts of power you're spending on compute, you're also spending like 80 watts of power on cooling. This can dominate your power budget.
Wow.
For the car. This can render cars like not useful.
Wow.
So you look at all of this, and the way people have traditionally tried to solve this is by making better AI or making better software. The problem is that the way, naively at least, AI has gotten better is that we've made our models bigger. And so, ironically, like the thing that we're doing to get to the safety is, even more utilizing these chips.
When you say making the model bigger,
mm-hmm.
You're saying a larger data set.
Larger data set.
More data coming in.
No, more parameters in the model.
Ah.
And so the models are getting bigger and the hardware isn't keeping up, right? So we can't, when we optimize to, say, use these chips less, we take cuts on accuracy. But if we optimize the models, we take hits on the hardware utilization.
All right, when we get back from this quick break, I know you're doing this moonshot. I want to hear about how you got into AI.
Mm-hmm.
And then when do you think your product will come to market?
Totally.
And if you succeed, which I think you're going to, what will you have enabled 5 years from now when we get back on This Week in Startups? If you think hiring is just as easy as posting on a job board or in classifieds, you are out of your mind. That is not what hiring great people is about. When you are busy growing your business, you need to reach the right candidates at the right time. You don't want some looky-loos. You don't want just randos applying to your jobs. You want the right people. You want the people who are on LinkedIn. They have 600 million members, and they visit LinkedIn to make connections, learn and grow as professionals, and discover new job opportunities. And LinkedIn members add 15 new skills to their profiles and apply to 35 job posts every 2 seconds. The velocity and the critical mass on LinkedIn is second to none. That's why LinkedIn gets you more job applicants, and it puts it in front of people who have the hard and soft skills you need to meet your requirements. Here you go. CMO Presh is posting a job right now on LinkedIn. You can see it here on my screen. And he's creating pre-screening questions to identify preferred candidates. This is critical. And he's going to select the budget, and he can see how many people will be looking at the job posting. Then LinkedIn auto-populates all the candidates they think might be a good fit. So they're working with you. You see what I'm saying? In the greatest talent pool ever assembled in the history of humanity. You're going to get $50 off your first job posting by going to linkedin.com/twist. I'm not kidding. LinkedIn loves This Week in Startups, and I love LinkedIn. I'm on it every day. You know that. I'm posting my clips from the show there. A lot of you are reaching out to me on LinkedIn, and I'm responding. LinkedIn.com/twist. Get the 50. Get a 50 from me. A 50 from JCal right in your pocket. Boom. Terms and conditions do apply. Go to linkedin.com/twist. And we've hired a couple of people by using this technique. Some of my best people have come from LinkedIn Talent Solutions. They do a great job. Okay, speaking of a great job, let's get back to this podcast. Welcome back to This Week in Startups. When my pal Travis from Uber invests in a company, They're going to be on This Week in Startups the next week. That's exactly what happened here with Marcus Gomez from Luminous AI. You can follow them on Twitter, Luminous, Luminous AI. And your website is luminouscomputing.com. How'd you meet Travis?
So just through, I mean, our investors were really critical in, putting this round together. I think, with all of the big names here, like with Bill Gates and Travis and Dara Khosrowshahi, and Luke, it's less interesting how we met them and more interesting sort of what they saw, because like you said, these aren't people that traditionally invest in this type of technology.
Yeah. What was the pitch to Bill Gates? How did you meet him?
Yeah, our pitch was this. So it's not, most companies have to justify, okay, I have a certain TAM, or I have a certain, is there product market fit?
Total addressable market.
Yeah. So,
and does the market enjoy and need the product?
Yeah.
The
interesting thing about all of these legends that we've brought on is that none of them asked us that question, because it's pretty obvious that a technology like this just necessarily must exist into the world. And so our pitch, this round has really been not whether or not, this thing is useful, but whether or not it works. And so honestly, most of our time was spent explaining to people who, either have seen some semiconductors or seen no semiconductors, how semiconductors work, how our specific chip works, because we do something very different than sort of the run-of-the-mill semiconductor companies. And, what the sort of concrete milestones that you need to hit in order to build a product like this, because it's just very out of domain for, traditional Silicon Valley, yet alone like traditional angel.
Yeah, if you think about Silicon Valley in 2019, we've had so much backed up enabling technology, which is what your company would fall into. I think you'd agree.
Yeah.
It's an enabling technology. In other words, you get this done, other people take it, and then they find the use case for it. We've had such a backlog of enabling technology. It's just this amazing fountain of continuous innovation, largely because I think of video games and phones. I think you would agree, pushing the envelope on graphic cards, GPUs, that we've been able to just have this huge reservoir to drink from. It's almost like there's this spring. But what you're saying is, let's build another spring. Let's build something that's just something people haven't seen before. It's enabling technology that in 3 or 4 years, you'll figure out if it works. And obviously, if you make things, it seems like you're trying to make things 1,000 times faster.
Yeah. So this is sort of like the reason why a company like this is interesting to do. And so for us, the next closest thing on the market is something depending on which metric you're looking at, anywhere from 100x to 1,000x worse. Both, on energy efficiency, on latency, on the amount of data that you can push through, on the energy per operation. And the reason for this is mostly out of necessity. You talked about this spring that we've been, drinking from for a while of enabling technology. The spring is
swimming in it.
The spring, in our opinion, is dried up. We're hitting fundamental limits of what we can do with AI. So here really simple, data point for you. OpenAI released this short blog post last year, and the size of the largest model is doubling, being published in AI literature is doubling every 3.5 months.
Wow. So the model...
The size of the models are doubling every 3.5 months. And the hardware is obviously not scaling up with that. I mean, chips aren't even being released at that fast
Moore's
pace.
law says the chips would double every 18 months. Is that still happening or not? Because I hear from people like maybe we're starting to reach the end of that.
Yeah, so Moore's law, I mean, we're struggling to put, Intel is spending like $100 million to tape out like a latest node chip. We're spending TSMC is spending billions of dollars just trying to shrink to the next node size. I think now what we're relying on is less just that node shrink, or at least what the traditional players are relying on is less the node shrink and more, okay, with the existing technology, like what are the other tricks that I can use to actually leapfrog to the next step. The problem is that this just only goes so far. And so, what we've done is we use an entirely different platform to solve a lot of the traditional problems. So concretely, we use light or photonics to solve all of the traditional places where these tricks in electronics only get you so far.
So instead of sending electrical signal, you're sending light.
Yeah.
So it'd be, am I correct in saying an analogy of an Ethernet cable versus a fiber optic cable?
Yeah, that's a fair
roughly
analogy.
For a layperson.
Yeah.
I guess it is the type of speed difference we're talking about.
Yeah.
When you're using an Ethernet cable, you feel pretty good about it.
Yeah.
Until you're on a fiber optic cable and you're like, what?
Yeah.
Yeah.
A very simple example. So, one of the things that every time you move a piece of data across a regular metal wire, you have to apply a charge across that wire. And so the amount of energy that you spend is more as the wire gets longer or as, you traverse the wire more times. In light, in photonics, this is a completely different situation. So it's basically you pay a one-time cost.
It's fixed.
Yeah, it's the upfront cost of generating the light with a laser. And then with the same energy that you spend to move a single bit of data across a metal wire, say a centimeter, you can move light a kilometer.
Wow.
And so, by switching to this platform, switching to the photonics platform to solve a lot of these problems, we're avoiding having to, sort of squeeze this sort of juice box that's already empty.
Yeah.
Right.
Yeah.
And we can
get
these disproportionate improvements in just how effective our chips are.
What does success look like? Let's say, and I'm assuming this is a 3 to 5 year process to build something like this?
Roughly for a first development kit. Yeah.
Okay. So earliest you'll get this product to market would be 2022 to 2025.
Something in that range.
So you got 3 years heads down, 4 years heads down. When you come up with that first product, or actually let's even go to like, say, the third gen. We're sitting here 10 years from now. If it works, and what are the chances it works, I guess is interesting. You wouldn't do it if you didn't think it was a good chance. If it does work, what would the world look like? What application can I not think of that all of a sudden would be conceivable?
So I think the first thing to note is that all of the technologies that were promised to us in the popular science magazines 10 years ago just happen. So right out of the way, self-driving goes from level 5 fully autonomous self-driving goes from not possible to possible. Yeah. Drones have the exact same problem. They have latency requirements, they have energy requirements, they have just a sheer amount of data they need to process.
Sensors, yeah.
Yeah. The drones go from not deployed everywhere to deployed everywhere.
To being consumerized.
Which
is mind-boggling when you think about it. Because those things, people would fly them and be like, look, I got it to stay in the air for 2 minutes.
Yeah.
And now we were on a boat in Australia and like the CMO of our company is like flying his drone up and down the beach across to the boat. And he landed it on the back of the boat's like, whatever they call that thing where you jump off and get on the jet ski kind of thing. You know what I'm talking about on yachts?
Yeah.
On your yacht, you just get that. He's landing the drone on the back of the yacht. Crazy, right?
Yeah. But he still has to fly it. The autonomous drones go from not possible to possible too.
Crazy.
Robots go from, possible in small scenarios to possible everywhere.
Yeah.
And
those Boston Dynamics videos are bonkers.
They're pretty crazy, but the reason why you don't see robots in your day-to-day activities is it's the exact same problem.
Too many sensors, too much data, bigger model to control, to solve for. Loading a dishwasher is a bigger model than picking up a grape because you got a lot of different factors. You got a lot more sensors, and then you got power, and then the thing's got to carry the power. So now every time you put more batteries in it, it gets heavier, which means it's burning more batteries, and you get into this negative cycle. Mm-hmm. It's a disaster.
Yeah, and that's just the technologies that are, were supposed to happen that haven't happened yet, right? Then there's the technologies that, nobody's even thinking about these. A really good example of this is drug discovery. So right now, drug discovery pipelines take anywhere from 10 to, I've seen up to 20 years just to go from inception to go to market. We don't really use computers to do true drug discovery. And the reason, there are some startups coming up now that are doing really great work on this, but the reason why we don't really do this yet is because our simulations are too slow. And so, one really interesting thing that happens is we go from not being able to use computers to discover drugs, via simulation to, okay, we can cut the drug discovery timeline in like half.
Yeah. Which means cutting the cost in half.
Yeah.
Which also means, I know this sounds bizarre, but rich people investing in things, if the window is too long, they get less interested, I find. Mm-hmm. So the older investors I meet are in a big rush to have this work in the next 5 to 10 years. Of course, they're going to be gone in the next 10 to 20.
Yeah, they'd like us to solve death pretty soon.
And just think about it. I'm going to work on the Taj Mahal and it's going to take 30 years. No, I'm going to build my smaller house. And it's I want to see this thing completed in a way. Mm-hmm. All right. When we get back from this quick break, you're doing photonics.
Yeah.
Light. I have been reading about recently people storing and doing computing in biology, in cells, in petri dishes, essentially.
Totally.
And then we've been hearing about for 2 decades, quantum computing changing everything. I want you to tell me, of those 3 paradigms, what are the pros and cons and potential points in time where they will hit market? And if they do hit market, what the pros and cons of each are when we get back on This Week in Startups. Are you struggling to sleep? Do you know how important your sleep is as a founder, as an executive, as an investor, as a human being? It's critically important. Well, you're not alone. 1 in 3 U.S. adults does not get enough sleep. Well, that is not shocking to me. You need to get great sleep, and not sleeping is going to affect all those cognitive functions that you need, like learning or problem solving or decision making. The sleepless are more prone to accidents, weight gain, don't I know it, and depression. I don't get depressed, but I do add the pounds. And when we sleep, we get more focused, relaxed, and happy. You know this. You know this in your heart. That's why we're partnering with our friends at Calm, the #1 app for sleep. You're going to get a library of programs designed to help you get the sleep your body and brain needs, including soundscapes, which are just wonderful. You put those soundscapes on and I'm just right to bed. I'm saying in single-digit minutes, I am knocked out. And they have over 100 sleep stories. And these sleep stories are designed with science in mind. They have the cadence and they have the authors and they have the words, and it just slowly puts you to bed. My kids love them and I love them as well. Hey, here is my CMO, Presh, and he is going through Calm and he's picking a great sleep story. He's going to pick Easter Island. Is he going to do Journey to the Stars? What is he going to pick this time? I wonder. Oh, he's going to pick my good friend, Matthew McConaughey. Okay. Let's get you to sleep. Get 25% off Calm premium subscriptions right now at calm.com/twist. That's right, calm.com/twist. Get 25% off calm.com/twist. 40 million people have downloaded Calm, and it was Apple's 2017 App of the Year. What is a good night's sleep worth? Priceless. Okay, let's get back to this amazing episode. Welcome back to one of the most fascinating discussions we've ever had on This Week in Startups. My guest is Marcus Gomez. He has raised $9 million from Travis Kalanick, Bill Gates, my friend Luke Nosset from Gigafund. Somebody else famous. Who'd you say before?
Dara Khosrowshahi, CEO of Uber.
Oh, yeah. Great. So you got the 2 CEOs. You got the old and new, old school and new school. When we left our hero, that's you, Marcus, I was wondering, photonics, biological computing, and quantum computing.
For sure.
Compare and contrast and educate us.
Yeah. So I would think of, first of all, I would think of this company less as photonics happens to be the tool that we use to build chips for AI.
Got it.
So I would really call this difference the difference between biological computing, AI computing, and quantum computing.
Okay.
To be totally honest, I don't know a ton about biological
Yeah.
computing, so I can't comment on it.
Feels like that's super nascent.
Yeah,
They're like, we stored, like some bits in a petri dish.
really exciting for like very, very niche applications, but in terms of, something that's going to make the self-driving cars outside work in the next year or two, it's not viable. Then there's sort of quantum computing, and this solves a very interesting set of problems. I think the fundamental problem is that the scaling just hasn't worked out so far. In terms of we still have to cool these things. That's not. Maybe it'll scale to a data center. It definitely won't fit in a car.
No.
Definitely won't fit on your cell phone. No. And then contrast this to what we're doing, right? And I think the thing that's, the thing that makes us stand out here is we want to put one of these chips into every single electronic device in the world. So AI should not just be this thing that's stuck in the cloud, or AI should not just be this thing that only Facebook uses to deliver better ads. Facebook is a thing that AI is a thing that should make your life easier. It should make the pain go away. It should give you the option to stop digging holes if you don't want to dig holes.
Yeah.
And the only way to do that is to give everyone the compute necessary to actually be able to use the AI on those platforms. And the technology we're building is built very intentionally to be able to scale to any of these applications, whether it's in a data center, or whether it's deployed into the real world, whether it's on your phone or your laptop, or in
so you see
some
it like
giant
the
rack.
same way Intel or Ethernet were put onto every motherboard, Wi-Fi, Bluetooth. It'll just be one more thing in every device.
If AI is the ubiquitous thing that it's being promised to be, then this is the necessary next step.
Yeah. Do you share concerns that Elon Musk and OpenAI have talked about? OpenAI recently said they were going to go from an open model. I had one of the founders on the podcast, and they were very open about everything they do. It's all going to be published. It's going to be available to everybody. And then they hit some achievements that they said, you know what? We are going to not share everything because we fear that in the wrong hands, this might be too dangerous. Where do you stand on how powerful AI is in the short to near term and regulation of its deployment?
Yeah, I think so. First of all, I don't personally know Elon, but OpenAI and that team are being pretty responsible by not letting that loose.
Why? What is their fear? If you can think about it.
I think we here in the Valley, and also in the world at large, systematically underestimate what AI can do.
Okay.
Right.
So you're in the camp of concern. Got it.
Yeah, like this is not just a thing that can do object detection. This is a thing that beat the world's best Go player. Right? Like this is the type of technology we're talking about. If used irresponsibly, first of all, could be bad for the world. Second of all, we don't even really understand why a lot of these models work. A large amount of the backlash in between sort of the old school of machine learning and the deep learning community has been a lack of good enough theoretical understanding for why these neural networks even work in the way that we think they do. And so
let's pause on that for a second. I think that's a very important moment. People create a neural network. Mm-hmm. They put a bunch of data into it.
Yeah.
It makes a decision. Mm-hmm. But somebody did not write an algorithm to say, make the decision this way. Yeah. It just made the decision. And the algorithm or the neural network itself cannot tell you and explain why it made the decision.
It cannot explain. So, for example, with Go, the AlphaGo Zero, what it does is it knows that it has to optimize for winning the game as winning the game as
that's it. And then the neural network does it.
Yeah, and all it knows is that okay, these are all the types of moves I can make.
Yep.
It never explains. This is why I think this is a good move, or this is why I think this is like the right move. It just does it, and you can sort of interpret what's going on because it shows you say probabilities. Mm-hmm. but it's not the level of granularity that you really want. I mean, for example, do you really want that same type of technology in a car where you're driving down the road and like let's say you built a very simple neural network to do stop sign detection. I just want to know if there's a stop sign. I want to know whether I need to stop or not. Right? This is the different, like this algorithm could have learned stop signs. It could have also learned that every time there's a stop sign, there happens to be a metal pole right under the red octagon.
Yeah.
And it might be looking for that metal pole. So then maybe you driving down the street, you don't see the red octagon, you see the metal pole, it stops.
Pile up, boom. Yeah.
Right? And
unintended consequences.
Exactly.
Second, what do they call it? Second factor, second order. Yeah.
Yeah, this is a second order issue. I think the
second order issue.
Now, obviously cars have fail-safes for this, so this doesn't actually happen in practice, but
right. And it's
this is the type of thing that can happen
and
with
self-driving
these models.
is narrow AI as constructed today,
Yeah.
except Elon, who is doing a neural network, I think. Yeah. What do you think of his chip? He put out a chip that he said is the most powerful one.
Yeah, I mean it's a good chip. I'm not sure whether or not it's sufficient for true level 5 self-driving. I think the consensus is honestly just pretty varied. What I will say is, for the workloads right now that most of these self-driving companies are running, it's not enough.
It's not enough. Yeah. What's interesting to me is, on a highway, it's flawless.
Yeah.
On the streets, I have self-driving also on my Honda Odyssey to keep keeping the lane, like the rudimentary. Like, I think it's a major jump between when I get off the 6th Street exit here and I'm in San Francisco and you drive through the Tenderloin or Market Street. That's a whole different problem to solve than the 280.
Yeah. I mean, this is exactly why this type of chip isn't enough, because on the highway, it's actually ironically, it's pretty constrained. There's only a certain number of things that can happen on the highway. There's only a certain number of things you can see. For example, you're never going to see a pedestrian on the highway.
No.
You're never going to see a pedestrian.
And if you hit a pedestrian on the highway, nobody's blaming you.
Yeah.
They're like, why is there a pedestrian on the highway? This person's committing suicide.
Exactly. But in these city environments, you have, orders of magnitude more inputs. You have more variable speed. Even just planning, a trajectory to get from, the beginning of the block to the end of the block might be very challenging if in the middle of your trajectory there's a person that happens to decide, okay, I'm going to jaywalk and walk across the street.
Yeah.
And for the level of safety that's required for sort of government regulations, but also for consumer adoption, again, the amount of compute that you need to do to get there is not enough, and that's including Elon's chip.
Yeah. Yeah. The thing I wonder is, and I think it's an interesting thought experiment, which is when we discovered nuclear energy, it became very clear in a very short period of time that it was something we needed to contain. The amount of fuel is now being measured in Iran and, North Korea, down to an incredibly finite amount to make sure that they do not break a certain threshold and able to create but one bomb because of how dangerous this technology is. When we get back from this final break, I want to know, which do you feel will be a greater danger to humanity? AI everywhere, in the hands of everybody, or nuclear energy in the hands of every nation state and everybody, when we get back on This Week in Startups. I want to tell you about a secret weapon I have here at inside.com, my company, and this secret weapon is called Rippling. You know Rippling, RIPPLING.com. Every minute you spend updating your company's employee data and systems is a minute that you're not spending on your core job, whatever product or service you're trying to introduce into the world. Thankfully, there's Rippling. It's the first and only platform that combines HR and IT. And they just put them right together. These are two things that are arduous and painful for every founder. What if you could just have those two things off your plate and done perfectly, without errors and quickly? Well, now you can. Imagine you hire somebody in just 90 seconds. You take care of their HR, payroll, health insurance, 401k, and that's not it. Then you get all their IT stuff done. You order their computer and you instantly set up their accounts in the most common apps that we all use, like Gmail, GitHub, Slack, and it's all in one simple onboarding flow. And that's why it won PC Magazine's Editor's Choice Award, and it's the top-rated HR and IT software on G2 Crowd. Here's an example of an employer-employee contract being signed for Inside.com. Tell us about yourself. Boom, you put your address in, you sign the documents. Boom, here we go. And we're done. We get everything done. We're hiring somebody, putting in their title, they sign everything, and boom, we're back to work on what we're building at Inside. It's a seamless experience, and everything is in one place. So if you're looking for an easier way to supercharge your employees and have your HR and IT run like a well-oiled machine, I want you to go to rippling.com/twist and get 20% off. That's right, Rippling, RIPPLING.com/twist, and you're going to get 20% off. That's an incredibly generous offer. Rippling.com/twist. Get 20% off. Okay, thanks, Rippling, for supporting the podcast and for supporting my company, Inside.com, and making us bionic, like we're superhuman now. Okay, let's get back to this amazing podcast. All right, Marcus Gomez is with us. He's the co-founder and CEO of Luminous Computing. It's a brand new company. They're doing enabling technology, something we used to do here in Silicon Valley all the time. It used to be actually the majority of what we did here. Now it's, sadly, a tiny fraction. Yeah. Everybody here wants to know about traction, total addressable market, product market fit, customer delight, NPS scores. Nobody wants to do the moonshot, it seems, anymore, but you're building a moonshot to build chips with AI on them using photonics.
Yeah.
Is the term, which basically means light.
It's just light.
It's just light, fancy word for light. That obviously uses a fraction of the energy and is faster.
That's correct.
So I think we've established what you're doing pretty well. And now let's go to the big picture. You have a vision of having the chip in everything. If we had nuclear energy and reactors and material and everything, that would be pretty
There's reasons why you might not want to do that.
Yeah, because radioactivity. So let's compare and contrast science and scientists and innovators like yourself and the people who worked on the Manhattan Project to this moment in today. Is that a fair analogy? And if not, how would you contextualize what we learned about nuclear energy versus the potentialities of general AI?
Yeah, so I think comparing to the Manhattan Project might be a bit unfair since that is just a weapon. I mean, like look at AI. There's two sides of this, right? On the one side, you have things like deepfakes that are just obviously extremely problematic. But on the other side, we are building neural nets that beat doctors who have been in the industry for 50 years at detecting cancer. We're going to end drunk driving as we know it. We are going to end any sort of labor-related injuries. We're going to let people just do what they want to do with no, both in their work environment and even in their personal environment with, things like assistance, things like just better content. And so all of this is to say,
the upside's huge.
The upside's huge. And so the question that, and this is the thing that personally matters to, all of the team, and it was a conversation me and my two co-founders had really, really early on in the company. I think the thing to know here is you can choose to use this technology for good or for evil in any sort of, world. But if you don't build the technology at all, then you don't get a say in how the technology is used. And so if we build our chip and we put this chip in every technological device in the world, that's really our only shot in saying how the course of the usage of this technology goes.
But you still took a little time to think that through. You have some concerns, do you not?
I have concerns that if this company doesn't exist, the AI will most likely be used for more harm than good.
How important is it that America win this race versus, say, China?
This is a very complicated question.
Let's get into it.
So,
because they're doing a Manhattan Project for AI.
I mean, everyone's working on it. This is of national security interest to every country in the world. Right.
Who's further ahead?
So I think it depends on what you're looking at.
Okay.
I think for semiconductors, the valley is still the valley. In terms of where the best chips are, and also for where the best talent for AI is. The best papers and the best research are still happening. At least a lot of it's in the valley. A lot of it's coming from the United States in general, from these world-class research institutions.
Thus, the reason we're being spied on so heavily.
Yeah.
And people are trying to get this. There's still a reason why we got a lot of Russian and Chinese spies here in America trying to get this information.
Yeah.
I mean, they're literally going to work for companies in Silicon Valley.
I am a seed stage company, and I consistently worry about, is my phone tapped? Are my emails being caught? Are the doors of my office locked? Because this is obviously a useful technology that can be abused. I think, in the case of the United States, we're definitely ahead in terms of every aspect of the technology. Now, if you want to talk about dissemination of technology, we're not the best. I think China has very clearly shown itself to be the best at fast dissemination of technology.
We see that in their CCTV, closed circuit television. I guess that's an old term for webcams.
Yeah.
They have a CCTV network
Yeah.
that has facial recognition that can find anyone who's not indoors or not in their apartment in seconds.
Yeah, and we're talking about a country that can build cities in very, very short amounts of time. I mean, this is
something about eminent domain and a dictatorship, essentially.
So I think
this is why we need Trump to have a third, fourth, and fifth term, so we can catch up and have a dictator of our own who says we need to make AI a priority. That's not what I'm saying. That is dystopian and crazy. We're going to win because we have entrepreneurs like you. We win, I think.
I think in most cases we win. And the question becomes not whether we win, but whether when we win, we use the technology responsibly, and whether we set the example and we set the norms for how this technology and where this technology is used.
Yeah, if you think about just the drone situation as a microcosm, we've done a fabulous job of mitigating what could have been a completely disastrous last decade of drones. They are now GPS geofenced, correct? Mm-hmm. They are speed limited. And some maniacs took them to Heathrow Airport earlier this year. I don't know if you remember Heathrow getting shut down.
I do remember this.
And they were zipping drones around there. Yeah. I don't know if they ever found those people. Take a look, Master Nick, if they ever found the Heathrow drone people. But I think it was a couple who were doing it. I don't know what their motivation was or if it ever came out, which that makes me more concerned. Yeah. Because if it was a bunch of kids, I'd be like, thank the Lord. It was just some dipshit kids.
Yeah.
Not Al-Qaeda or somebody with an axe to grind. If you just think about the damage drones could do with a modest amount of AI or just remote control, I mean, it could be 9/11-esque. You could just shut down the entire country's aviation system by sending one of those into planes taking off and just happening to hit one jet engine sucking a drone in. I wonder if it would go down or not. Or if it had a payload on it, it would go down.
On the flip side, though, think about, I mean, we can paint this dark world, right?
Yeah.
But there's another, again, like, AI is not a weapon. AI is a tool that can be used in either way.
Yep.
And so again, we're talking about a world where nobody ever gets hit by a drunk driver again. We're talking about a world where medicine goes from imprecise to perfect every single time.
So the good outweighs the bad. I agree with you. I agree.
I think it requires a high degree of integrity and a high degree of just accepting this burden of responsibility. But
people also forget about laws. If you think about laws, we have laser pointers. Yeah. You point them at a jet or a helicopter, which some idiot does, they just put somebody in jail for 4 or 5 years for doing that. Let me tell you something. You get a laser pointer, you're not going to point it at a helicopter or a jet. You know better now.
Yeah.
When you see that person on the local news go to jail, this is why people were like, you can't stop Bitcoin. I was like, really? Tell me about Napster. Tell me about having a VPN in China. Like, there are people going to jail in China for having VPN software. And going to jail in China is probably not going to be very pleasant. And if deep fakes become an acute issue here, it's going to be very easy for the government to say producing deep fakes and publishing them without a disclaimer on them that this is a parody and it's a deep fake will result in you going to jail. Now, me saying that right now sounds crazy. It also sounded crazy in the early days of the internet that somebody using Napster would go to jail. People were like, nah, you can't stop peer-to-peer. Nutella, this, you can't stop it. And it was like, yeah, you can stop it. Travis got a lawsuit for $250 billion when he released Scour. And he was like, well, it's just software. And they were like, yeah, but it's software and you got the Last Action Hero on there. I don't think it's going to... I don't think it's going to work.
Yeah, I think the critical thing is making sure, and this is a thing that's, we're actively planning on working on in the next, before we even ship our first product, is to make sure that, we educate the people who don't know, what are the good things that AI can do and how do you regulate this thing correctly? Because the one thing that you do consistently see is that when the government messes up regulation, like the internet just walks around it.
Yeah.
Right.
Yeah. And then it's kind of a dance, actually, now that you say it. I'm thinking it through. It's like, yeah, if you overreach, then the market typically steps in. So I think it's instructive to think about music because people just wanted to listen to whatever song they wanted to, whenever they wanted to.
Yeah.
And radio and CDs did not provide that. They just wanted a jukebox with every song in the world.
Yeah.
And for 15 years, we asked for it, and they didn't give it to us. Then they gave it to us, and we gave them $10 billion a year for it. But they fought us for 15 years instead of taking our money. And the music industry went like this to CDs, and then came crashing down, and now it's like halfway rebounded. And it will come, obviously, back. So the market has to also think this through in a way. And I think this video is super instructive. We'll end with this. The Boston Dynamics guys training their robots a little too severely here. This is Bosstown Dynamics. You see the robot getting up, and they're moving the package around. This is an Amazon robot trying to pick up a package and getting hit over the head with a bottle of wine. Looks like they got him right in the. Oh, wait! What's going on here? He's pulled the hockey stick that he's being beaten with away. And he's now throwing boxes while getting spray paint and fumes on him. Have you seen this video?
I have seen this video.
It's the most hysterical video ever.
I actually didn't see the logo in the bottom.
I know. I think they had to. That was not on the original one. I think they had to add it because people thought it was. And here he is blowing an air horn on it. And the poor robot's getting whipped. The video gets worse and worse. He's being whipped and being sprayed with paint and having an air horn. And now they're shooting him with a gun while him trying to pick up a package. This is what we don't want to do because one of the things we've learned about robots and computers, they do have a long memory. And these robots are not going to take it well. And then this is where it ends up. The robot finally kicks a guy in the nuts, sidekick, throws a box at a guy, knocks him out. They run, and he's got their gun. So there's a lot at stake. Please don't put your chip in these robots.
This is the difference between a stop sign detector and a thing that detects the thing next to the stop sign.
It's hilarious.
It's the
Look,
same
there's the
problem.
guy in the green suit getting beat up by balls. That is hilarious. It's like literally the best viral video ever. I don't know what they're selling. Marcus, what's the chance it works in the next decade, what you're doing? Where do you put your chances at? Because that must come up with investors. Hey, what's the chances this works?
Like I said, our pitch is that the R&D here is done. The R&D, my co-founder Mitch, he spent the past 10 years of his life with an entire team at Princeton developing the core R&D, like doing the core R&D for this technology. At this point, we've boiled down the problem of putting a supercomputer on a chip to an engineering problem. And every problem that we've solved is a problem that someone else in industry has already solved before at scale. And so our chances are basically, based on whether or not we can hire the right talent. And
so it's not a matter of if you'll get there. It's
just when.
When? 5, 10, 15. But it's a prize worth spending a decent portion of your life on.
Yeah, this is a blueprint. This is not just a design. It's a true blueprint in the sense of I can tell you exactly what we have to do every month for the next 3 years to get to the product that we want to get.
Got it. I think you're going to get there. Congratulations on the funding. And I'm going to let you get back to work, Marcus.
Thanks so much.
Continued success. If you are a genius and you want to work for Luminous Computing, I'm guessing Marcus at luminouscomputing.com might work.
Marcus at luminouscomputing.com is the way to reach me. We're hiring aggressively right now.
What do you need? You need PhDs or you need hackers?
I need everyone.
Okay.
I'm looking for product people. I'm looking for BD people. I'm looking for semiconductor people who are tired of building 2Xs and want to build 1,000Xs. I'm looking for software people who are excited about redesigning the compiler for the first time in, the past 20 years. I'm looking for AI people who are tired of, building a better search algorithm or building a better ad delivery system and instead want to build the next thing for the world.
If you've been banging your head against the wall working for Facebook, wondering why,
come work for us.
Go work for Luminous Computing and try to do something in the world that's world and humanity positive. All right. We'll see you all on This Week in Startups next time. Bye-bye.